Hi, in this video, we'll be talking about routing. So let's recap a little bit. So far we know that the internet is about getting digital information from point A to point B. We want to be able to send bits over a network so that two computers can talk to each other. Now, how do two computers find each other in this massive network? Well, every device on the internet has its own unique IP address. Now, this is an old version of the IP addressing system. This is an IPv4 address. The problem with IPv4 is there are only 4 billion unique addresses, and pretty soon we'll have well over 4 billion unique devices on the internet. So we're in the process of switching to IPv6, which uses several more digits to represent a single address. So there are several more combinations, several more possible addresses. With IPv6, there's over 30 undecillion unique addresses, so we'll be fine for the foreseeable future. Now the problem is we don't really want to be using these IP addresses when we're browsing the web. We don't want to have to remember all these massive strings of numbers. So we use the DNS system to map domains to IP addresses. It's like an address book mapping human-readable names to machine-readable IP addresses. So we can have a domain like support.google.com that maps to this IP address, or www.codehs.com that maps to that IP address, and these names are a lot better for us to use. So at this point, we know the destination. We know where in the internet we're headed. We have that IP address. The question is, how do we make the journey? How does information actually get to that destination? Well, introducing routing. Routing is the process of sending data between two computers on the internet. The data is sent through routers that determine the route that the data takes. So in a simple network, we need a way for every computer to talk to every other computer. Rather than making individual wires, individual connections between each computer in the network, what we do is we put in a router. So every computer just connects to the router, and then if the computer on the bottom left wants to talk to the computer on the top right, it will just send that information along to the router, and the router will forward along the message. This way we don't need connections going between every single computer. This isn't scalable when we start having millions, billions of devices. The internet is just a larger version of this simple network. Two computers are connected through a massive network of routers, and these routers are connected in intricate ways. So let's say these two computers wanted to send messages to each other. The computer on the left would write up a message and mark it with a from address and a to address. It's from IP address 2.2.2.2, and it's sending it to IP address 9.9.9.9. So the computer will forward that message along to the first router. From here, the router will look at all of its connections and forward on the message to the router with the lowest cost. And in this scenario, cost doesn't mean least money spent. Cost is actually a calculation of several things. So cost is calculated based on how close is the IP address of this router that I'm sending it to the final destination. Is the router that I'm sending it to trustworthy, or has it been failing a lot lately? And is the connection fast? Am I sending it over a fiber optic cable, or am I sending it over something like radio? So it calculates the connection with the lowest cost and forwards the message along to that router. So let's say it calculates that the top middle router has the lowest cost. It would forward that message along, and then the same process would repeat. It would look at all of its connections and say, what is the best place for this message to go? How is it getting closer to its final destination, and is it reliable? So let's say it calculates the middle router on the final row, it forwards it along there, and now the message can get all the way to its intended recipient. So now the computer on the left can read the message, it can write up a response, and then send it back through the same process. It marks it with a from address and a to address. And then using this destination IP address, the routers will route the message back to 2.2.2.2. So forward this along to this computer. Maybe this router calculates that it's actually better to go to the bottom, so it'll go there. And then that one might forward it along to this router, that one might forward it along to this router, and finally it gets forwarded to the final computer. So that is how two computers can communicate with each other. Now, what's interesting to note is that there's a lot of redundancy here. There are multiple paths that exist between 2 points. And this may seem redundant, this may seem like extra work, there's too many connections. But this is actually a good thing. We don't want single connections between every computer. We want to have multiple paths because this improves the reliability of the internet. This makes it so that the system is fault tolerant. If an individual router breaks, which happens all the time, the system doesn't stop working altogether. Individual routers can break left and right, and the system still works fine. So if we look at this, this is only one of many paths between these two computers. If that router on top were to get overloaded, or if it were to crash or break, or there was an earthquake and it just got taken out, that's completely fine because now we can use this path. And maybe that bottom right one gets taken out, that's fine because we can use this path. So this redundancy is a good thing. It makes the system fault tolerant. So it improves reliability, and it makes the system scalable. A lot of times it's hard to create a system that as you add load to it, as you add a bunch of machines, it still works. In this case, adding more and more routers, that actually makes the performance better because now we have even more reliability and more redundancy. So by scaling up, we actually get better performance. So this is how information is sent across the internet. It is routed in indirect ways through a vast network of routers to get to its final destination IP address.